an issue before. Alright. I'm not able to share the screen. Yeah. Is this visible?
Yes, sir. Yes, sir.
So what we did in KMnO₄, we did the acidic reaction, right? Yeah. So in K₂Cr₂O₄ and KMnO₄, one thing is common, that is in both the situation it will undergo exactly in the same way and all the product will be same. Example, Fe2 positive convert into 3 positive in both situation. Same I negative convert into I2, Sn2 positive 4, Sn2 negative, S2 negative, neutral zero state and goes on. Okay. So that's why when it comes to the K2 Cr₂O₄ and KMnO₄, it is exactly same. But this is not the situation in every condition. Remember, this is not the situation in every condition. Example, if you take in neutral condition or slightly acidic in nature, then situation will be different. Samarth, why? Why when we take in the neutral condition or weak basic condition, product is different? Because acid was responsible for the gain of electron. Okay, acid was responsible for all the gain. Now you don't have acid. What will happen here? Mn7 positive will convert into Mn4 positive. Okay, so what is the general reaction? You have MnO4 negative react in the 4H positive condition and there will be 3 electrons. It will produce MnO2 plus 2H2. Is this correct? Is this correct? Any doubt?
No, sir.
This is wrong because I said neutral or basic condition, but here you have 4H positive. It means acidic. Correct? So make sure all of you, all six are there, na? All uh, six of you key. See what is given in this situation. How many are there? Six. Pratigya, Barinder, Chandana, Samarth, Sania, and Sara. Here we are talking about the basic medium. When you are talking about basic medium, you cannot have H positive in the reactant. Understood? So what happened? This reaction will be common. Ki MnO4 negative, it means it is like KMnO₄. In the basic medium, it will convert into MnO2. So oxidation stage from +7 convert into +4. Why it is special? Because in case of acidic medium, it was from 7 to 2. Now it is from 7 to 4. So less intense. That's why you will see there is a difference. And here you will have OH negative ion because basic condition. Just give me 1 minute. Hello guys, am I audible?
Yes, sir.
Yeah. So that is the difference. In case of acidic medium, there is a difference of 5 from plus 5, sorry, plus 7 to plus 2. Here you have difference of 3, correct? Here you will have gain of 3 electron. That is the biggest difference. And that will be asked in your exam. Nobody going to ask simple question like this because it's easy to do. But if they give in the neutral or weak medium, then you will be confused. Like Chandana, you were in the board exam last year. So were you confused more in the like acidic basic medium and neutral medium? Strong basic, what happened?
Yes.
Correct?
Yeah.
So focus on this, guys. And because of this, even product will also be different. Why product is different? Because electron transfer is different. Example, in this situation, you will see कि iodine, where in acidic medium it was converting into I2. Here it is not I2, iO3 negative. So addition of oxygen, oxidation number will still increase, but in different way compared to the acidic medium. Ask me your question. Any doubt? Any doubt, guys? Same way,
No.
if you take S2O3 2 negative, it will convert into SO4. Do you remember in acidic medium you did S2S convert into S? One thing is common. Even in this situation, there is a oxidation increase. Example, here from minus 1, it is increasing to plus 5. Here 3 to the 6, 4. From plus 2, it will convert into plus 6. Still there is oxidation, but in different way. Any doubt? And sometimes same manganese can undergo oxidation and reduction at the same time. Example, if you take Mn2 positive, this will convert into Mn4 positive. Manganese is causing oxidation of manganese. Okay, any doubt? If you take HCl, it will convert into the chlorine, correct? Because Cl minus 1 will convert into 0. This is again oxidation.
Sir, one doubt.
Yes.
Sir, taking HCl, won't it become acidic medium?
When I'm taking HCl, it will.
Become acidic medium, right?
Yeah, it is acidic medium.
So you are considering basic medium where
No, HCl is producing chlorine.
yeah.
You have logical question. Ki sir, HCl is itself is a acid, correct? Then how you are taking in basic medium? I'm going to add this point. HCl is converting into chlorine, but by itself. Okay, so for this, we don't need KMnO₄. Don't need KMnO for this. Got it? Even in the NCRT, it is given in the very special note. Okay, so I'll show you NCRT also. Class 12th, chemistry part 1, D&F block, open chapter. Are you getting any background noise?
No, sir.
No, sir.
See, see this. In neutral and faintly alkaline, all these things, but Potassium permanganate titration in presence of HCl are unsatisfactory because HCl is oxidized itself to the chlorine easily. Correct? Why? Because H2O, two hydrogen can form H2O easily. Correct? So I wrote the exactly same thing, and that's why it is very special in this particular situation. And in NCRT, you have only this portion, and this HCl is very special. Okay, any doubt?
I got it.
So, what is special in this KMnO₄ if we compare from yesterday? First, uh, I need different color, green. One, we make KMnO₄ from MnO₂. First point, pyrolusite. MnO₂ is responsible for KMnO₄. First step is K₂MnO₄ formation, which is green in color. And if you add acid, then it will become purple in color. 3 point. MnO you take for the preparation, you make green color and then purple. Parallelly, you can also compare with how you make FeCr₂O₄ convert into Na2CrO4, then Na2Cr₂O7, then K₂Cr₂O7, right? For comparison, preparation. Second, in case of basic medium, you will produce K₂MnO₄, means green color. In acidic medium, KMnO₄, purple color. Structure is almost like the potassium dichromate, tetrahedral in shape. Both tetrahedral. Okay. Acidic medium, it gained 5 electron. In K₂Cr₂O7, it gained 6 electron. How do we know? Because chromium 6 positive convert into chromium 3 positive for one chromium. 2, 6. Okay. In case of basic medium, same KMnO₄ will convert into MnO₂. Okay. And these are the all these undergoing oxidation, same like K₂Cr₂O7. But neutral and weak medium is special. Why? Because when you change medium from H positive to OH negative, due to change in the reaction, it's like that's the reason why we use KMnO₄ in the titration purpose, because it's easy to identify chemical. Based on the acidic and basic medium, everything will change. Correct? And these are the three example where iodine, instead of converting into I2, it is converting into iO3 negative. Okay. One. Sulfur, where it was converting into H2S into S, here sulfate form. And manganese itself can undergo oxidation as well. But for chlorine, you don't need KMnO₄, because chlorine itself can undergo chlorine. HCl can convert into chlorine. Sarah, what will be the other product in this situation? And what is the other reaction? Chandana, you tell me, because you did this before.
Sir,
HCl is converting into chlorine. How is that possible? Because
sir, I'm not
it
it.
it react with the oxygen, it will produce H2O vapor, and chlorine will remain. Correct? You can take example 4 molecule of HCl, here 2 molecule, and then this balance. Correct? Any doubt?
But I
So
had,
HCl, yes, Samarth asked.
sir, in basic medium, we get a difference of 3 electrons, right?
Yes.
So can you explain how IO3, I minus to IO3 minus?
Here you have a difference of the six. So that's why for this you need 2 KMnO₄. Okay, example, if uh, you are writing reaction with the iodine, so what will happen? KMnO₄ when react with the iodine, one iodine and some water molecule, because water molecule will provide the basic nature, correct? So we know KMnO₄ will convert into MnO₂. This is plus 7, this is plus 4. So there is a difference of 3. But you also said ki IO3 negative. So iodine is converting from -1 to plus 5. So difference of 6. So iodine is losing 6 electron, but magnesium is gaining only 3. So what will happen?
Got it, sir. So 1 mole of K₂Cr₂O₄ could do the same, right?
Yes,
Okay, got it.
because there was a difference of 6. So
Yeah,
1 mole was enough. Right? So, and but iodine will be only 1 mole because balancing. Right? Remaining thing you have to add OH because you are showing that it is basic medium. Now everybody ask me if you have doubt from KMnO₄ and K₂Cr₂O₄. Guys, ask your doubt, Sarah.
No, sir, nothing.
Pratigya, Pratigya, all of you can tell directly fast key. Yes, sir. No doubt, no doubt, no doubt. Is
Sir,
it?
No doubt, sir.
Yes, Anya. Yeah.
सर कैन यू प्लीज एक्सप्लेन कि Mn2+ से जब Mn4+ होता है उसका रिएक्शन कैसे लिख सकते हैं हम लोग?
Definitely. So you know manganese is converted into Mn2 positive to 4 positive. Example maybe MnSO4. This here manganese is 2 positive converting into MnO2. Correct. And maybe your KMnO₄ that is undergoing a reduction can convert into the MnO2 and can also form K2SO4, right? So what is happening in this case? I will write here properly. If you take manganese oxide, that is sorry, not manganese oxide, potassium permanganate, you react with the Mn2 positive, Mn2 positive in presence of the water. Why? You want to maintain basic medium. So what will happen in this case? It is correct. Still not balanced. Correct.
यस सर.
So if you take 2, 3, it is 5. Now it is balanced? No. Water is not balanced. So basically what is happening, remember, this is not disproportionation reaction. It is opposite of disproportionation reaction.
Com proportionation reaction.
Exactly. Where in this comproportionation reaction, two different elements form the same oxidation state from plus 7 and plus 2 is forming common oxidation state plus. Understood? And this is also given in the NCRTC. Any doubt?
सर बट हाउ कैन वी डिस्टिंग्विश कि किसका प्रोडक्ट फॉर्म हुआ है मतलब?
दोनों का कॉमन ही हुआ है ना, दोनों का ही कॉमन है. So KMnO₄ converting into MnO2 or maybe like manganese sulfate is also converting into MnO2. So both are forming same product. Any doubt?
नो सर.
So let me know if anybody have question from this topic. Otherwise, we can move to the next part. Application. You know, KMnO₄ is very popular oxidizing agent.
Yes, sir.
Barinder, what are the chemical that can act as oxidizing agent? Is it only KMnO₄ or K₂Cr₂O₄? HNO3 can also act as oxidizing agent. Correct? These are the popular oxidizing agent. Any other oxidizing agent that we use that cause oxidation of other? CrO3 can also act as a mild oxidizing agent because chromium is present in +6 state. H2SO4 can also act as oxidizing agent. So you will ask, sir, how to identify whether a compound is oxidizing agent or not? If any element is present in highest oxidation state, then only reduction is possible. Make sense? See, here it is +6, +6, +5, +6, +7. These are the highest oxidation state possible for these elements. So what will happen? Only reduction is possible. If only reduction is possible, it is a very good oxidizing agent. Any doubt, guys?
No.
Yeah. So both are done. Let me show you some question. Some question, neat question we can see today.
Sir, what about PCC?
Pyridine chromate. Yeah, it is also a mild oxidizing agent. It is oxidizing agent. Where is, because PCC we use to convert alcohol into aldehyde only, right? Yeah.
Yes.
Chemistry. What was the chapter name? D and F block. Sorry? In D and F block, paramagnetism. Okay. Where's it? Spin only, spin only. Why we are not getting D and F block? Pair of lanthanoid, copper. This ionization enthalpy. Ionization enthalpy. Not a single question from, yeah, he got. No, but this is from the electromagnetism. No, sorry, electrochemistry. Why there is not a single question? Metal displacement, zirconium, hafnium. Not even a single question. Yeah. What is the answer, guys? What is magnet? K2MnO₄. Permanganate, KMnO₄. Both are tetrahedral. What is the reason?
So overlap of p orbitals of oxygen with D.
Overlap of,
So
exactly why?
also is
Because
B option.
B option, correct. Why? Because just imagine we have manganese and oxygen. Manganese have its electron in d orbital and oxygen have its electron in p orbital. That's all. Correct. And there is a double bond also. That's why pi bonding involved. So NEET is is not either asking question or asking like too easy question. See, when in neutral or faintly alkaline KMnO₄, like weak alkaline, is treated with Ki. Ki means iodine, I negative, right? Iodide ion convert into
IO3 minus.
3 minus.
exactly. And people say Odisha NEET 2020-19 was very, very difficult, right? Usually people say that. Name a gas that can readily decolorize the KMnO₄.
SO2.
SO2. Why? Because SO2 will convert into SO4. Done. Correct. Reason why? Because sulfur is present in +4, it can easily convert into +6 oxidation state. Correct. It can easily convert into, SO2 will convert into the SO4. I will add this also. Where is our notes? Here, SO2 will convert into SO4. Okay, 2 negative because +6 oxidation state. Who left? Barinder have network issue, I guess. So tell me, guys, is NEET question in this case is too easy to deal with? Lanthanoid. Yeah, same question. Which of the following correct when SO2 is passed through the K₂Cr₂O₄?
Option B.
Option B. Whenever it react with the SO2, it will convert into
Decolor.
SO4. SO4. No, that was for KMnO₄, right? It is saying ki green color already. But sulfate is more stable. And chromium 3 positive is green in color. So it is not decolorized. Understood? Any doubt? We have a lot of question from this. We'll solve question of the magnetic moment. Because magnetic moment is very popular question from this chapter. Who is here? Sania, what is the formula of magnetic moment?
Sir, n into n+2 whole root over.
Correct. So, magnetic moment, guys, is telling us whether a compound is paramagnetic or diamagnetic. Magnetic moment. Paramagnetic or diamagnetic, or if it is paramagnetic, is it a strong paramagnetic like paramagnetic, or it is weak? This is represented by nu, and nu formula is n+2 under root Bohr magnetone. What is n here? N is the number of unpaired electron. N is number of unpaired electron. Okay. So, Samarth, I think we did, Samarth and Sara, we did this in coordination compound also, right?
Yes, sir.
In valence bond theory. Okay, so if n is unpaired electron 1, then what will happen to this one? 1 plus 2, 3 under root 3. It will be 1.73 Bohr magneton. If it is 2, 2 plus 4, it will be under root A. Can you say 2 under root 2? What is 1.4? Approximately 2.8 Bohr magneton, right? If you take N3, Chandana, what will be value? This is, I said, 2.
Root 15.
Root 15, because 3 multiply by 5, 2 extra. And under root 15 will be slightly less than 4. Correct? Slightly less than 4, 3 point something. I don't know like what will be the exact number, but very close to like 3.8, 3.9, I guess. Bohr magneton. Samanth, if n is 4, what will be new value?
So less than 5.
Slightly less than 5.
Yeah.
4 point something, 4.8 something. And if n is 5, Pratigya, what will be the value?
35.
35. So it will be slightly less than 6, right? And if n is 6, it will be, Sarah,
Root 48.
48, slightly less than 7, because 49 is 7. Correct? Now, if you know this, because I have seen many questions in this PYQs, Bohr magneton, Bayer's reagent. What was the question? Which of the have same spin only magnetic moment of this case? You have to calculate what is the magnetic moment. By the way, remember one thing. Key, if you have some n value is not 0, it means it is paramagnetic because unpaired. Correct? If n value is 0, it means all electrons are paired. Then it will be diamagnetic material. Correct? So whether it is paramagnetic or diamagnetic, it can be explained by this. How to calculate here? Let's see this open with. See, in this case, what will you see? You have to calculate magnetic moment. I will tell for first option and then remaining 6 you guys will tell. Zinc 2 positive have 3d10. No unpaired electrons, so n value will be 0. Sakti titanium is 2. So it will be 3d2. Correct? 3d2. What will be an electron? 2. How do I know? Because titanium atomic number is 22, 3d2, 4s2. Now you are looking for the 2 positive, 3d2 only. Only 2 electrons are present in 5 orbital. So what will happen? 1, 2, 3, 4, 5. So 1, 2, both are unpaired electrons. So in this case, magnetic moment will be 0. And in second case, it will be under root 8, slightly less than 3. Any doubt, guys? Now, one by one. Pratigya, you will calculate for chromium, Sania, iron, Sara, titanium, Samarth, copper. Who else is there? Did I miss anyone? Sania, Chandana, I gave to you vanadium. There are 5 people, na? Pratigya, Chandana, Sania, Sara, and Samarthya. What is your magnetic moment in case of chromium? Guys, fast, make it fast.
Sir, root 15 for vanadium.
Vanadium 2 positive. Yeah, root 15. Copper, Sadhana,
Yes, Randy.
0. Copper 1 positive means 3D turn.
Yes, sir.
सर
Yes,
सर Fe2+ का होगा 4.8 समथिंग.
doesn't matter. Like you are getting 24 under root 24.
यस सर.
So Fe2 positive, 3d6, so 4 unpaired electron. 4 into 6, yes, correct. Chandana, Sara, and Samarth.
Sir, copper says 1.73. Cu plus or 2 plus?
Cu2 plus you did, na?
Yeah, 1.73.
So this is only 3d9.
Yeah.
So only one unpaired electron. Okay. And titanium 3 positive,
The root 3.
root 3. So is this correct? If we say who is doing chromium 2 positive, Pratigya, you will get 4 unpaired electron. That's why in magnetic moment, even you are not supposed to calculate magnetic moment. Just check what is the n value. If n value is same, then magnetic moment is same. Okay, so always calculate only unpaired electron. Question will be done. If you see in case of iron and chromium, it will be 4. So correct. Here it will be one unpaired electron. In case of copper, one unpaired electron. Correct. So can we say answer will be B and C? Do you have option B and C? Yes, D. Any doubt, guys? Any doubt?
No, sir.
Do we have, because I have seen many questions here. Magnetic moment, magnetic moment. See, spin only magnetic moment in the same for which of the following? Tell your answer A, B, C, D like this. Make it fast. We already did. What is the number of unpaired electron in this case? Chromium 2 positive, manganese 2 positive, iron 2 positive,
सर Sc3+ में एक अनपेयर्ड कैसे?
0, sorry. 0 na? 3d1 4s2.
यस.
3d1 4s2. So 0. So what will be the answer? Done. No need to apply formula. Yes or no, guys?
यस सर.
Yeah. So answer will be B and D. A. spin, length, period, diamagnetic. For this, you need electronic configuration. Oh, good. Any other question we have seen from this? You have lot of questions from lanthanoid contraction in this. See, same again and again lanthanoid contraction. Chandana, what do you mean by lanthanoid contraction? Here it will be value 2. Here it will be 5. Here it will be 1. Here it will be 4. Here it will be 3. Na? Hello. Hello. Maybe your voice is breaking. Hello. Hello. Good evening, Anita. I'm still there, but about to finish, like doing the last question. It's okay, I understand. So I'll share video. So okay, okay, finish it and then send me notes. Okay, okay. Yes, guys. So if you do this, na, everything become easy for you because now you have to calculate n value, right? In case of cobalt, start from the cobalt 3. So cobalt is 3d7 4s2, 3d6 4. Chromium 3, 3d5 4s1. You remove 3d3, n value 3. Fe3 positive 3d5. Nickel 2 positive 3d8. 3d8 means 2 unpaired electron. 2 means. Any doubt, guys?
No, sir.
That's why
No,
you
sir.
need practice. Because see, having understanding of the subject is different, and the speed is different thing. Speed come with the practice. Like when you did, okay, I know for n2 value it will be under root 8 for 5, 35, 3 will be there for 1 and 4, 24 and 3, 15. Then everything becomes easy. You can make it fast. Understood? So we finish K₂Cr₂O₄. Then second KMnO₄, and third we did magnetic moment. From tomorrow onward, I will take slightly longer class, like minimum 1.5 hours. So in next 2 class, I'll finish this chapter. Pakka. Maximum 2 class. Because only from for today I have extra class in the night. After that, I'll have more time for you guys and we'll make it fast. Like for every chapter, I will take only 2 class for theory. And I'll make sure in every class I cover 50% portion. Okay, because I'll get slightly more time. Is this enough for today?
Yes, sir.
Send your notes.